The function of two variable in xy is defined by this has a saddle point at among these. We need to find at which point this function is showing saddle point. To find this or related terms are critical point, critical point, stationary point, stationary point, and local extrema. These are few terms related to these problems or somehow correlated. Each stationary point is critical point, but every critical point is not a stationary point because critical point is where gradient is 0 or this is not defined, and this will not define in the sense either partial derivative with respect to x or with respect to y is not exist or both not exist. But a stationary point is only where gradient of f is 0, means partial derivative means this and this is 0. Local extrema is point of local maxima or minima. These are few terms. To find critical point, this is condition as explained, and we need to check fx, fxx, fy, fyy, and f square xy and their sign, and fxx, fyy minus f square xy sign of this. For saddle point, this should be less than 0. If this sign is equal to 0 or value of this one is 0, then need to investigate further. If this is greater than 0, then point of extrema means either minima or maxima. That will depends on the sign of either fxx or fyy. If one of them or both is negative, then point of maxima. If positive, then point of minima. Now come to the concern as saddle point. Function in two variable is given by 3x square y plus 4 y cube minus 3x square minus 12 y square plus 1. So first partial derivative with respect to x will be 6y x plus 0 minus 6x and again 0. Fxx will be 6y minus 6. Fy will be 3x square plus 12y square minus 24y. Fyy will be 6x fyy, because this term is not containing y, so this will be 0. 24y minus 24. As this is fx, so fxy means again differentiate this one with respect to y, 6x only. For a extrema point, put fx equal to 0 and fy equal to 0 where both are 0, not only one, both is 0. So fx is 0, it means 6xy minus 6x is 0. This implies 6x as common, y minus 1 is 0. This implies x is 0 or y is 1. Now fy is 0. This implies 3x square plus 12 y square minus 24 y is 0. Now from this one, because we need to check where both is 0, then substitution will help you to find critical points. Put x equal to 0 in this one, then 12 y square minus 24 y is 0, means put take x from from this equation as 0 and value of y what are coming from this one. So 12 y is a common, so y minus 2 equal to 0. So y is 0 and y is 2. So value of is 0, and when I put x 0, then I also obtain value of y is 2. So 0 and 2 are y coordinate. So these two are points. Now when y is 1, put in this one, then 3x square plus 12 minus 24 is 0. This implies 3x square minus 12 is 0. Take 3 as a common, x square minus 4 equal to 0. This implies x equal to plus minus 2. When I put y as a 1, then value of x is 2, and when I put y is 1, value of minus 2 also. So these 4 points are my critical point. Now we need to investigate derivatives, either partial first order partial derivative or second order partial derivative at this point. So partial derivatives are here. So going to be check partial derivative. At 0 0. First we are going to check at 0 0. Fx x into fyy minus f square xy at 0 0. So at 0 0, f put 0 here, this one will be minus 6 into fyy, put 0 here, so minus 24 minus x square, so 6x whole square means 0. So this value is positive. Now at this point 0 comma 2, 12 minus 6, 48 minus 24, this value is again positive. Now 2 comma 1, 6 minus 6, 24 minus 24 minus 12 square. 12 square is 144 and this is 0, so less than 0. And again 0 comma 2. Again, minus 2 comma 1 value is less than 0. So these are saddle point. So 2 1 and minus 2 1 are saddle point. What are saddle point? 2 1 and minus 2 1 are saddle point. But given option is only minus 2 1. So option D will be right choice.